So I've just realized that the last 4 videos didn't have me in the picture, but that's fine. You don't need to see my face if you can see what I'm talking about on here. So this video is all about a process that you probably did all the way back in year 7 called chromatography. So it's about using the splitting of dyes in a substance to create a chromatogram, which is a picture of the elements of that particular substance. So let's have a look here. This is all under the same kind of subsection. We're analysing organic compounds in water. In particular, we're going to look at the application of high performance liquid chromatography, HPLC. And it's fine for you to just call it HPLC. You don't have to write high performance liquid chromatography. Again, we're going to look at calibration curves. They work the same way as they did for UV vis, which is lovely. And also this thing called retention time. And these are RF values as well to determine the concentration of a soluble compound in water, for example. So previously we were looking at concentrations of substances as they were. This is about splitting the substances from the solvent. So let's just have a look at chromatography in general and think about what it might be. So chromatography is a technique, and so in booklet 17, you'll notice we've skipped over the first page, which is about organic contaminants. Please feel free to have a read, but we're not going to be examining you on that topic. So chromatography is a technique used to separate substances present in a mixture. It can be used quantitatively and qualitatively, same as the UV vis. And it's dependent upon the type of chromatography, whether or not you get quantitative or qualitative data. So usually we use it to identify organic compounds, so things that contain carbon, but sometimes you can use it for inorganic too, from gases to polymers. All right, so there are different types of chromatography. The first type of chromatography is the one that you're probably most familiar with. If you remember doing any of the forensics activities where you looked at the different types of pens, you have done paper chromatography. So you put your inks on the origin, which is that line down the bottom that you can see here. So this is where you put your ink or your dye or your mixture of dyes, and you dip it into the solvent, but you keep that origin above the solvent line. The solvent moves up the paper. Yeah, it gets absorbed by capillary action and moves up the paper. And as a result, different substances separate out at different rates. So you can see that this one part of it is red, one part of it is purple, and one part of it is blue. So that's paper chromatography. The next type is thin layer chromatography, which works almost the same way, except it's not paper that we're using. We're using this thing called a thin layer plate, and you have to use a specific chamber. It's a little bit more accurate, but it still has this key here. It has a mobile phase like this solvent here, which could be water in paper chromatography, and that moves up the stationary phase, which is the plate in this case, to separate out the substances. And I'm going to come back to those in a second. This one is the one that we're going to spend most of our time on. Our focus is on high performance liquid chromatography. And then the last one that we're going to look at just briefly is one called gas chromatography, but you're not going to be examined on that. So how does it work? I'm going to link to this video on Sector and also in the playlist so that you can have a watch, because it's a really nice kind of video outlining how HPLC works. But essentially we need to look at these two words here. So we need to look at this word called absorption versus adsorption. All right, so absorption, you can see here, is got to do with a substance fully absorbing or going into the stationary phase. Adsorption is where it is just attracted to the surface of the stationary phase, and that might slow it down. So by stationary phase, I mean something that doesn't move. I don't mean stationary as in pens and pencils. I mean stationary as in stop. All right, so all types of chromatography, so this is in the how does it work bit, all types of chromatography have a solid phase. That's called a stationary phase, and you can say stationary with an A. So S-T-A-T-I-O-N ARY, not ERY. ERY is the pens and pencils that you use. And it also has what we call a moving mobile phase. So the stationary phase is fixed, and the mixture kind of is separated, moves through that stage, or along, or adsorbs along the top of it. So here is the mobile stage. That's usually a liquid, and it moves up the stationary phase, which would be your piece of paper, your column, whatever it is. So the separation happens, yeah? So as it's moving up, different colors separate. We've probably seen this before. But the reason this happens is for two reasons. The separation happens by continuous adsorption onto the stationary phase, followed by desorption into the mobile phase. So it kind of is moving along, and it gets attracted to the stationary phase, and it stops for a minute. Then it comes up, it gets desorbed into the solution, comes along, gets adsorbed onto the solution there. So you can see here is our adsorption along the edge there. So here we go, adsorption, you've got the molecules coming along, sticking to the stationary phase, desorption, back on. So this is linked to polarity. Why is it linked to polarity, or how is it linked to polarity? Think about it. If you want the substance to adsorb onto the stationary phase, you might have to consider what you're going to use for your stationary phase. What are you going to use for this plate if your substance is polar? Because if your substance is polar and this is polar, they're going to repel each other, and it's just going to pass along and never want to adsorb. So you want to have a kind of difference in polarity, and that's going to help you with your chromatography. So how fast this process of adsorption and desorption happens is dependent on how strongly it adsorbs and how readily it dissolves or desorbs into the mobile phase. So it's really important that we make sure we choose the correct or an appropriate mobile phase and an appropriate stationary phase, depending on the substance it is that we're going to facilitate the separation. And we'll go through some rules for that